So this is the webinar for the AirQo African Air Quality Prediction Challenge. We have an amazing host, AirQo, who has provided the data and the challenge. We have worked with AirQo in the past, and it's always such a pleasure working with them. Through AirQo, this competition is sponsored by the Mozilla Foundation, so we are so happy to have Mozilla on board as well. Just to go through the agenda, we're going to hear a bit about Mozilla, then we're going to hear about AirQo and the project, and then I have a starter notebook that we're going to walk through, and then we're going to have some Q&A. If you have a question for a specific speaker, once the speaker has finished talking, you can mute yourself. Find that person. Yep. Once the speaker has finished speaking, you can ask them questions straight away, or you can save it for the Q&A session. You can also put your questions in the chat if you are scared you're going to forget them. So I'd like to introduce Mehan Jayasuriya, the Senior Program Officer at Mozilla Foundation. Over to you, Mehan.
Thank you, Amy and Richard. I'm really happy to be here. Thanks for inviting me to be a part of this webinar. My name is Mehan. I am a Senior Program Officer at the Mozilla Foundation, and I oversee the Mozilla Technology Fund. A lot of you are probably familiar with Mozilla primarily through our work on the Firefox browser or our work on Thunderbird. Mozilla has a kind of 25-year history at this point of building and maintaining open source software. And in tandem with that, we have had various programs over the years that have sought to kind of support other projects in the open source ecosystem and kind of pay it forward and help support the next generation of open source projects. So for a few years, we had a program called the Mozilla Open Source Support that funded dozens and dozens of open source projects. And for the last 3 years, we have kind of been supporting open source projects through the Mozilla Technology Fund, which is our newest and kind of latest generation version of a program like that. Mozilla Technology Fund does calls for proposals in specific areas. So we try to seek out projects that are kind of aligned with Mozilla's strategy. We try to seek out projects that are making a difference in the world that we'd like to support and where we see open source technology as something that can help make an impact. So this year, our theme for the Mozilla Technology Fund call for proposals was environmental justice in AI and climate change in AI. So we're looking for projects that either can help to measure and mitigate some of the climate impacts of AI technologies or projects that are using AI in a way that can help address a pressing issue in the environment. We're very excited this year to have 10 different projects that we're working with. They run the gamut. We have a lot of air quality and air monitoring projects this year, which is exciting. But we also have folks who are using computer vision to look at deep sea life. We have folks who are using GPS data and satellite imaging to look at things like sand mining and illegal mining in the Amazon rainforest and all sorts of things. So encourage you all to go and look up the Mozilla Technology Fund and read about all 10 of the projects that we're working with this year. We're really excited about all of them, and they're working together in a cohort to kind of provide peer mentorship and peer learning and all of that kind of stuff as well. But AirQo is one of those 10 projects. We're very excited, not just about the technology and the potential for AirQo to kind of use open source technology to solve a pressing problem, but also about the community aspect of it. And so we're really happy to see this initiative to kind of bring folks from the community into the project, encourage folks from the community to help kind of problem solve around some of this stuff and to build out some of these pieces of the AirQo project. The thing that you're all being invited to provide input on is really a very core part of the project and a very core part of the tooling that they're going to build over this year. So yeah, really excited. Hope that some of the folks in this room will have some ideas that can be helpful and can help kind of AirQo kind of move this project to the next step. And yeah, just thrilled to kind of be a part of this and to be supporting the AirQo project. I think I'll pass it back to you, Amy.
Great, Mehan, thank you so much. We love the work Mozilla is doing. Just a note for participants, please can you keep yourself on mute unless you have a question, then please do unmute yourself. or raise your hand. Next, I'd like to hand over to Richard, a data scientist at AirQo. He's going to tell us a bit about AirQo and the reason for this project. Over to you, Richard.
All right, thank you, Amy, and greetings to you all. My name is Richard Sserunjogi from AirQo, Makerere University. I'll be telling you briefly about AirQo and introduce you to the project. Amy, can you confirm that you can see my screen?
I can.
All right, briefly about AirQo. AirQo is an initiative from Makerere University that was founded in 2015 to close the gaps in air quality management in Uganda and other sub-Saharan African cities. Through leveraging technology innovations to influence action through contextual evidence. Our vision is to have clean air for all African cities by developing low-cost air pollution monitors, deploying them in different cities, and making the data accessible to the different stakeholders through our digital platforms. Over time, we've managed to establish a network in over 10 African cities on the continent. We've deployed over 200 monitors and engaged with different partners and duty bearers, including students, women, children, etc., to ensure that the solutions you provide lead to interventions for the most affected citizens. This is an overview of the AirQo air quality monitoring solution, where we develop low-cost monitors here at Makerere University, and we deploy them in selected urban centers across Africa to establish a high-resolution network like what you see here, and then make this data available to the different stakeholders for actions that might be taken to reduce air pollution and its effects. We started in Kampala, as I mentioned, but over time we've grown the network to over 9 African countries in several cities, including Kampala, where we started from, Jinja, Gulu, Kabale in Uganda, Nairobi and Kisumu in Kenya. In Nigeria, we have presence in Lagos, Abuja, and several other African cities, including Bujumbura, Dakar, Senegal, Douala and Yaoundé in Cameroon, Manica in Mozambique, Pretoria in South Africa. I think it's great to see that we have colleagues from South Africa here, Antananarivo from Madagascar, and Accra in Ghana. Of course, we also developed these platforms to be interoperable. They also enable us to provide access to other data from different net air quality monitoring providers, including the US Embassy. So as briefed earlier, these platforms enable us to ensure the solutions we develop, the data we provide, reaches the people who are most affected, including women, the youth, and children. And at AirQo, we aim at increasing youth engagement and participation in tackling air pollution through data and technology, simply because, as you know, Africa is the youngest continent, having like a median age of 19 years. And the youth have a voice and a role to play in ensuring that air pollution is mitigated across the world. We engage them, all the youth, in STEM and data-related challenges to ensure that we empower the next generation of scientists who will tackle these global challenges, including air pollution. We've hosted a number of challenges on Zindi and other partners. On Zindi, we've hosted, I think right now there are like 4 or 5 challenges. We've hosted challenges with Fruit Punch AI. We've worked with policy to host challenges, and we also engage schools to ensure that we empower and bring the air quality discussion to schools so that the students and children are empowered about air quality related issues. Now, with that context and background, with what we do at AirQo, I'll dive into the projects that we are focusing on for this challenge, which is artificial intelligence for equity, where we're estimating and validating PM2.5 levels using satellite and ground observations in selected African cities for environmental justice. Maybe for our colleagues who might not be aware of what PM2.5 is one of the indicators of air quality, and they are simply small particles of a diameter that is 2.5 micrometers. They are very small that they can penetrate into our body, liver, lungs, etc. And research has shown that they are the most dangerous air pollutants. To give some context of the project or the air quality monitoring landscape in Africa, previously, air quality data has been lacking in many African cities, as, you see the illustration above compared to the rest of the world. But of recent, in the last few days, low-cost approaches and innovations are closing the existing gaps in African countries. If you look maybe 5 years ago, what the air quality monitoring landscape was in Africa, you would find that, most of the countries or cities didn't have any air quality monitoring program, or if there were, they were very limited. But over time, due to innovations, there has been a steady growth of air quality data across the continent. However, we're still having challenges in achieving optimum monitoring resolution for major cities on the continent. And now the utilization of satellite-derived PM2.5 estimates offers us an opportunity to complement the ground monitoring data that has been established in several cities on the continent. So with this project, we aim at estimating PM2.5 levels from satellite observations for 8 cities with varying ground monitoring resolution using appropriate machine learning algorithms, and validate these estimates using available ground-based observations in these cities. There are 8 cities in, I think 7 or 6 countries. That's Kampala and Gulu from Uganda, Nairobi and Kisumu from Kenya, Accra in Ghana, Lagos in Nigeria, Bujumbura in Burundi, Yaoundé from Cameroon. The goals for the project were to host a competition that was already launched and that we were participating in, to ensure that a wider community of data scientists contribute to developing precise, accurate machine learning models for estimating and validating these PM2.5 observations in the selected cities, and then develop and deploy the machine learning models into the AirQo digital platforms so that the data is used, the data or the estimates are used to complement to the existing data sets that will be used to increase awareness and empower local communities and stakeholders on air quality issues in relation to environmental justice. Yeah, just to quickly offer more insights, I think, on the challenge or the competition, which is termed AirQo African Air Quality Prediction Challenge. We want to see if we can use Sentinel-5 data to predict air quality around Africa for environmental justice. And yeah, we using ground data from the AirQo network from these cities. Then the satellite data is obtained from Sentinel-5 data that was extracted from Google Earth Engine. The competition is going to run for 3 months. I think, yeah, some few weeks I think have passed, but it will be closing on 16th June. And we have some prizes for the winners, 3,000 USD that will be distributed accordingly. The breakdown, I think, was listed on the competition page. And after the competition ends, we shall have some short-term placements with, yeah, some of the team that will have emerged as winners to ensure that, yeah, these models are incorporated into AirQo digital platforms to ensure that, yeah, the communities in the selected cities can have data from these models. And also there will be 3,000 Zindi points that will be given to, yeah, the various participants. That is it. At high level, maybe I'll also acknowledge the various funders who have enabled this project, Mozilla for supporting it, and our existing partners in the different cities, plus Zindi for hosting the challenge. Thank you very much. Over to you, Amy.
Thank you so much, Richard. If you have any questions for Richard, put them in the chat. Otherwise, let's wait until the end. I'm going to share my screen now. I'm going to share my entire screen. We're just going to go through the competition. So here is the competition. If you go on to compete on Zindi, and you can search AirQo, and here is the competition. The competition ends on the 17th of June, so you've got about 2 months left. Tuesday next week, this will be updated and the recording of the webinar will be there, so you can always come back to it. We've talked about the description. The evaluation for this project is the root mean squared error. You can think about this as standard deviation, so how far are you away from the true value. You can read more about the RMSE error metric by clicking on this link. We mentioned the timeline again, as well as the prizes, which Richard has mentioned. Past winners of AirQo competitions have interned with AirQo before and have thoroughly enjoyed their experience. So this is definitely a contract you would like to win. If you're new to Zindi, we do have some videos on how to get started. This video shows you how to enroll, where to find the data, how to download it, and how to make a submission, how to create a team, how to update your profile. And then if you don't have Python on your local machine, if you're new to data science, then we recommend using Google Colab. This is a free Google product that you can use to run notebooks. There are paid tiers, but for this competition, the free tier available to everyone is more than enough. And then we have the rules. For this competition, you can work either as an individual or in a team of up to 4 people. If you would like to share code with another team or another person that's not in your team, please make sure that you share it publicly, such as on the discussion forum. And please don't hide any code or share privately, as that's considered as cheating and colluding. And then I just want to mention the public-private split. It's a 25-75% split. um, to talk about the data. If you'd like, I think there's 80 or so features in this data set. And they are pulled from Sentinel-5P as mentioned by Richard. And each of these gases has sub-variables. So you have the angle that the satellite was at, the depth it was taking it at. And so if you'd like to know anything more about each variable, you can go onto this link, click the bands. And so for sulfur dioxide, here are all the different values that we pulled. What's great about Sentinel-5P is that it's a free resource. All you need is a Google Earth Engine account, which is free to create. And this means that AirQo's solution, or the solution from this competition, which AirQo is going to integrate and expand on, will be applicable across the whole of Africa and even across the whole of the world. So you will be making waves. You can download all the data that's needed. Zindi has already done a train and a test split for you. So this is the train and the test. And then I've just uploaded an AirQo starter notebook that I'm going to be going through on this call. So you can follow along or you can get it later. If you have any questions, please make a comment or create a discussion post. If you have anything to share or something that you think might help another user, that's another great way to use the discussion board. And then you can also see where you are on the leaderboard. If you submit the sample submission, you will be 141st on the leaderboard with a score of 25. And then you can also go and view yourself on the leaderboard. Great. I'm now going to run through the notebook. If you haven't used Colab, oh no, this one's connected as well. If you haven't used Colab before, when you open up, just Google Colab, when you open it up, in this top right-hand corner, there's a button called Connect. So you click on Connect, you wait about 30 seconds, and now this notebook is connected. Then you click on this button over here and you can click upload. You can navigate to your downloads folder and here's all the files, and I just uploaded them. I've already uploaded, so I'm going to click cancel. You can either close or minimize this bar just so you can see your screen better. I've already run this notebook. As you can see, it was run recently, 10 minutes ago, just to double check it works. So the first thing we do in every notebook is we import the libraries we need. This is important that we import them all at the start of our script, especially if scripts take a long time to run, or if you want to leave it to run overnight. This has happened to me before. I start working, I then import a script in a library in the middle of my code. I go to bed and I wake up and it has crashed at importing that library because it wasn't installed or something. So we always run it in the first cell to ensure that all our libraries are there. We've got pandas and numpy. Pandas for exploring the data frame. We've got matplotlib and seaborn. These are great for plotting. And then we have our machine learning metrics or packages. We are importing the mean squared error. We are importing a train test split class. And for this starter notebook, we're using a light gradient boost regressor. You don't have to use light GBM. You can use whatever you want. But for this starter notebook, this is what we've decided to use. When we've created a variable called data path. Because I'm pulling straight from this directory, I don't need to have a path. If I wanted to, I could use this path. If you have mounted your drive, which means you would have clicked this button, you can put your path in there. If you're working on your local machine, put your local path in there. And this is just a great way to make sure that you know where your files are. So we read in the train, the test, and our sample submission, and I'm going to show you what each of these files look like. So this is our train. We have, each row has a unique ID, and then we have a site ID. I'm going to go back to the competitions page, and I'm going to go to the data page. The train set contains cities Kampala, Lagos, Nairobi, and Bujumbura. And then the test set contains completely different cities, Kisumu, Gala, Accra, and Yaoundé. They are completely different cities, but both East and West Africa are recognized in both train and test. So maybe that's something you want to keep in mind when creating your models, that there are East and West cities. East and West cities could experience different seasons at different times, which could mean something. So I just wanted to bring that to your attention. And then coming back here. So we're looking in the country Nigeria. We're looking in the city Lagos, and then we're looking at the site ID 6531. In the city Lagos, there are more than one sites that these devices, these IoT devices, have been put up. There could be as many as 100. So each site ID is a different device in the city, in the country. The device has a latitude and longitude, so you can plot them if you'd like. And you can also just see that distribution between East and West. We tell you the date, the information the satellite passed over, and the date that information was collected at the site. You might see that there are some missing dates. On these missing dates, it could be that the satellite either didn't pass or that there was no recording on the device for some reason. The satellite passes at approximately the same time each day. And so the way we've determined the hour is we've chosen the hour for the site that is the most dense or has the most variability in the PM2.5 reading. And it's also the most dangerous time because it's normally around noon. So that means there's been enough time for buildup of PM2.5 across the morning. Here we have those 80 or so different variables that you can go and read up about. Lots of them will be nans, so you need to figure out how to deal with missing variables. There's lots of different ways to do that. And then your last column over here is your PM2.5 or your target. Just going to pop over to here to see if there's any questions so far. Yes, you can. Okay, it looks like there's lots of questions. I'll come back to them. The test looks almost identical to the train. The only difference is that it does not contain this final column, the PM2.5, as that's what we're predicting in the test. The other differences is that there are the different cities, as mentioned before, as well as the different site IDs. Over here, this is what our sample submission looks like. So for this ID IH for this site on this date and at this hour using all these features in the top row. Or you can drop, or you can create more features. Can you predict what the PM2.5 is? And we need to replace this 0 with that, with your predicted PM2.5 value. So now that we've gone through what the data set looks like in depth, we can now see some plots, do some EDA. This is just a start. Please add more, dig deep. So our target distribution, we can see that most values are less than 100 and they seem to be clumped around less than 50. You can go into this more granularly. So something that I would do maybe before submitting is I would check my submission file that I've made just to make sure that my submission file follows a similar curve. If I'm predicting that all values are around 400, then something might be very wrong or very right. Here we have some outliers in the target. Again, we're seeing that most values are around this 25 PM2.5 mark, but we do have values that stretch all the way up to 500. So how would you deal with missing values? Also, how would you deal with outliers? And then how would you also deal with missing values? We can see that not many values are correlated, so this is quite a hard competition. Carbon monoxide, the column density, seems to be the highest correlated. So there might be a need to drop some variables or to create some new ones. I'll leave that for you to figure out. Our modeling, this is my favorite part about machine learning, especially when it's just the start, is it's actually quite simple. We are going to create our train section, and we're just going to drop the PM2.5, and we're going to set the target as the PM2.5. So we're taking the train set Zindi has given us, and we are splitting it further into a train test split. So we can create our model, LGBM, and fit it to the train data Zindi has given us that we've resplit. We then apply our model to our test set from our train set. That's quite confusing. And after running this, we get a local RMSE score of 17. So this is just running it on the train set. We've now got this model. This is a starter notebook. So 17 probably isn't the best. Maybe it's brilliant. I think we can improve on it. I can now take this model that I've initialized over here and trained, and I can now apply it to the test set Zindi has provided. So this is applying it to that big data frame that's missing the last column. I get the predictions and I add it to this last column in the sample submission file. So here I've got IDIX, and after running my LGBM model, I predict that it gets a PM2.5 value of 17.97. Once I've run this, I get my submission, which I can download. I can go to the competition page and I can click submit. And I get a score of 14.2, which means I've improved my position of 142, and I'm now 53rd on the leaderboard. I, of course, will remove myself from this position to give you a fair chance, but if you run the starter notebook, this is the exact score you'll get. I want to point out again that while running it on the test set, on the training set, we got a local IMRS E-score of 17. Once applying it to the Zindi test set and scoring it on the Zindi platform, we get a score of 14. Just keep that in mind, keep the private-public split in mind, and keep the different cities in mind. I'm going to jump back over to Zoom and I'm going to see if there's any questions. Once I've answered all the questions on Zoom, I'm going to open up the floor for live Q&A. Oh, brilliant. I'm so glad you guys got to see the screen. Correct, it is more of a regression challenge. Yes, there are a lot of missing values in the data set, mainly due to what the sensor is picking up on the satellite. So you can also read up a bit about Sentinel-5P. Resources to learn, I recommend starting by just reading up about Sentinel-5P. Lots of work has been done with it, so you can go into Medium, maybe even Geeks for Geeks would have something on it. Yes, thank you, Jim. Notebooks at the bottom over there. Use of external data sets. For this competition, no, external data sets are not allowed. If you win the competition and are invited for the contract with AirQo, you can maybe raise exploring different data sets, but that is an option. Or don't use it for this competition, but it's an option to raise it with AirQo if you get the contract. I've done a lot of talking. If anyone would like to ask a question live, please do raise your hand. Katende, yes, do you have a question that you want to ask? Feel free to unmute yourself. I might have asked your question already. We're going to stay on this call for another 3 minutes, just in case a question pops up. Feel free to raise your hand, put it in the chat box. But do we have any final words from Mehan and from Richard?
I guess I'll just say good luck. Hope that everybody got the information that they needed from this webinar to get started. And yeah, we're really excited that you know, the solution to these problems could come from the community, and that there's an opportunity for folks to kind of jump in and participate in this project. So thanks everybody for joining today.
I think I'll also add my voice to wishing everyone luck, and also thanking the members here for joining in. We can have more discussion, I think, on the Zindi discussion chats. We shall be following up. In case of any questions that pops up, feel free to put it there. Members will be monitoring the forum to see how they can share. Thank you very much. Back to you.
Richard. Katende, just want clarification on the data sets that will be used by the AirQo team. So, Richard, I believe that when you implement this model, you're hoping only to use the Sentinel-5P to predict ground PM2.5. Is that correct?
Yeah, I think that's the setup currently. But yeah, we are open, I think, maybe after the competition to explore different, in case there is any additional data set that can be used to make the results more accurate. Yeah, we shall look into exploring them.
Great, thank you so much. Thank you to everyone who's joined us tonight. This recording will be made live next week, and we look forward to seeing you on the leaderboard and on the discussion forum.